Hello people, in this video we want to look at the indices of thermal comfort, basically the temperature what we are focusing on, or just comfort, right? Thermal comfort. How will you measure it? Indices of thermal comfort. So basically we are looking at air. So air will have oxygen, carbon dioxide. Is it enough if air has a certain amount of oxygen? Will you be happy? No. You have to have some humidity, temperatures, which is also specific, right? So that's what defines comfort. What is discomfort? Discomfort is a subjective sensation. Some people will feel hot, some people will feel cold, they feel uncomfortable. That is discomfort. So generally, what is comfort zone in terms of temperature? In terms of temperature, if you have 25 to 27 degrees centigrade, it is comfortable, they are saying, in terms of temperature, okay? Just temperature if you consider. Below that, you will feel cold, right? Cool, they have written. And above that, they have written hot, okay? So basically, this is just one parameter of comfort, temperature, right? But is that enough? No. This is not enough to tell whether thermal comfort is there. Thermal comfort is not just temperature. It also needs some breeze, right? So you need some movement of air, some humidity, everything. So you have to look at those parameters. So first they said it could be temperature. No, it's not just temperature. Is it temperature and humidity? Then they said, oh no, it's not just temperature and humidity. Something else. What is that? Cooling power? So they brought in here a Kata thermometer which has wet and dry, right? So that will measure the cooling power. So you remember the Kata thermometer video where you have seen this Kata thermometer, right? So basically it is an alcohol thermometer. It will measure the cooling power of air. What will it tell you? It is telling you the cooling power of air. So you have the dry and wet, okay? So you have the dry and wet Kata thermometers. Look at this. So dry and wet. So here you have the indices of thermal comfort. They are telling you here. Dry Kata greater than or equal to 6. Wet Kata greater than or equal to 20. Rate of cooling is Kata factor divided by average cooling time. Okay guys, don't go into so much. Just know here that using this Kata thermometer, you can know the cooling power of air. So this cooling power of air also, they have considered as an index for thermal comfort. Then what they said is, let us combine all these three things and bring up an effective temperature. So they used this Kata thermometer, wet and dry. They got a temperature reading, humidity and movement of air, and they came up with effective temperature. So effective temperature, they came up with. Then after some time, they corrected it, saying that instead of the dry Kata, they will take the globe thermometer reading. Okay. Instead of the dry Kata, just a globe thermometer reading. So that will be the corrected effective temperature. So that will give you everything. The temperature, humidity, movement of air, cooling power of air, everything. And this is the index of thermal comfort now. Look at this graph here. Guys, we are looking at now the effective temperature chart. Okay, this will have the wet and dry bulb reading. So here you have the wet bulb reading, right? Here you have the wet bulb reading, right? And here you have so this is the wet bulb reading. And here you have the dry bulb reading, dry bulb temperature. And here you have the velocity of air shown here. You can see the velocity of the air. And somewhere here they are saying this is effective temperature, right? They've drawn a line here. And here they are saying 65 on this side, 80 on this side. And somewhere here around 70, 80 you can say. So this is something like an effective temperature they have come up with. So if it is dry bulb is 80 Fahrenheit, what will it be in Celsius? That will be around 26 degrees Celsius. So that kind of makes sense, right? But then they said that no, this won't do. This effective temperature chart won't do. Let's make a correction. So they brought in a corrected effective temperature. So instead of the dry bulb temperature, they took the globe thermometer. See, they're taking the globe thermometer, okay, instead of the dry bulb temperature. And look at this graph now, the same graph, the little difference, okay. So here you have the wet bulb thermometer, wet bulb temperature. And here you have the globe thermometer temperature. And here you have the velocity of air in feet per minute, and here you have the corrected effective temperature. But here they didn't mark anything as such, right? The corrected effective temperature. This is CET. What is CET? Corrected effective temperature. What is CET, guys? Corrected effective temperature. So here they are saying that at present effective temperature and corrected effective temperature are used as the indices of thermal comfort. Currently they are using this only, right? And there is also something like sweat rate, etc. So you can consider that also. Predicted 4-hour sweat rate, etc. They are including something, but you remember only this much, okay? So you have corrected effective temperature and you have effective temperature chart, two things: wet, dry velocity, wet, globe velocity. That's it, okay? So in this video, we are done with indices of thermal comfort. Remember, comfort is not just about oxygen. It is about humidity, temperature, cooling power of air, everything, okay? That's all for now, guys. In this video, you have learned the indices of thermal comfort. That's all for now. Bye-bye.